Hello sir, my name is Vansing. I am from Computer Science Department and today I'm going to present you about the Codebar system. And before I'm going to my topic, I would like to show you some points that I'm going to present in a table of 10. The first one is the meaning, the second one is what it's used for, and the next one is type of barcode, the universal barcode, code bar, and the problem to solve in the barcode. And the first one, definition. What is barcode? A barcode is a visual representation of data can be read by a machine. As you can see here, it consists of black and white. It is a line black and line white color. And the code, the number under here, it is a code that can be seen in the barcode. And next, before we go into detail in the topic, the first thing we need to know is the history. What, who, and who was inventing the barcode? The barcode. The barcode was invented in 1948 by Norman J. Woodland and Bernard Silva, the two students from the Drexel University. As you can see here, this is the first invented of barcode. It looks like a circle and some kind of a bullseye designs. And the purpose of creating this barcode is to improve that they want to improve their management and custom checkout of the supermarket industry. And this barcode is involved into this series black and white line color in 1970. And the next point is useful. What does barcode use for? Barcode is used as a serve as a quick and efficient way to identify item. Yep. Barcode is used to identify item. It used to read what kind of item is it, what location that the item is produced, what does the item uh, have in their stock or something like that. And how does it work? How to know that how to know about this item? The first thing is we can use barcode scanner or mobile app. Call it a Codebar scanner. You can find it in App Store or Play Store. It can scan the product identity by just scan on it, and in this device you can see here the scanner. You can see in the supermarket they use it a lot. They use it to scan the item. It is quick because it saves time for the cashier to in order for the supermarket to check out the item quickly. And the next point is talking about the type of code bar. Code bar, there are two types of code bar. The first one is we call a one-dimensional code bar, and the second one is the two-dimensional code bar. Yes, the 1D code barcode or one-dimensional code bar is you already saw it in the previous slide, and it's also known as the linear barcode and made up of vertical line. Yep, it's some kind of similar to definition. And the difference is about the another one is the 2D barcode. The 2D barcode is more complex than the 1D barcode because the 2D barcode is can store more information than the 1D barcode, because the 2D barcode only you can only access it through phone uh, by scanning it, and the other name which we call it a QR code. The QR code, the 2D code, 2D barcode, you can use it like to access some kind of information for your own personal use, or you can use it for business, something like that. It is like For example, like the teacher have one QR code for the student to access to the exam. So he sent the QR code so the student can scan it and they can access through another website and can log into the exam paper or something like that. It is we call barcode, and the 1D barcode is like you can scan it to see the identity of item, what kind of item, like a shampoo or Coca-Cola or some kind of many other drinks, vegetable or something. Yeah. And the next point is we're talking about the universal products barcode. The universal product barcode is being used nowadays. And what is the universal barcode? The universal barcode is commonly used as a system for identity the entire product. Yeah, how it works. As you can see here, the universal product barcode it contains 12 digits, and the first 6 digits from 0 to 5 it represent the company prefix, or it can be a country like import or export to. And from 0 to from 6 to 0 digit it represents the item reference number, and the last one is to check about digit. And another point is talking about the code bar. What is Codebar? Codebar is a symbology developed in 1972 by Pitney Bowes Code. It is also known as the other name, such as Codebar and any other something like this. Yeah, you see the difference between the universal Codebar and Codebar is it in here it consists a third digit, which it also include the letter in here. And move on to the example. Here is the universal product barcode. And in order to find the universal product barcode, this number is true or not, the first thing we need to know is the formula. According to this formula, C multiply U must equal to 0 in order for this universal barcode is true. Yeah, this C is equal to check digit and U is equal to universal product code. And this formula, I take it from the book chapter 8 code. And in order to find the last digit, the first thing we need to know is C. We already we don't know what C is it, but we can assume it because in 10 digit we can assume C equal to 0101 as a 12 digit and U equal to this universal product here, and we multiply and sum it up together and we will get the result in 68 plus D. And 68, as you already know, it is a decimal number. In decimal number it contains only 0 till 9. So in here is bigger than the decimal number, so we need to take 68 modulus 10 and we will take only the remainder. 68 subtract 10 we get 6 and the remainder is 8, and 8 here plus D. And as you already know, in order for this number is true, we need to make it equal to 0. So D here must equal to 0 because because you already know 10 modulus 10 equal to 0. So 8 plus 2 equal to 10, 10 modulus 10 equal to 0, and 0 here uh, is the calculation in the 10 digit. So it means that this universal product barcode that provide is true. And move on to the exercise from the book. In exercise 1 is find the parity check code vector for the binary vector U. And the first one, U equal to 1011. And as you read this exercise, you notice that in this exercise they want us to find another last check digit, and it is in the binary. And you already noticed that binary. What is binary? Yeah, binary is the best tool normally called system that use only two digits, 0 and 1, and it cannot be 3 or 4 or something like that. It cannot be up above 2. It only 0 and 1. So the first thing is we need to assume c equal to 1, yeah, 1 here, and we compute it together by this formula c multiply u, and we will get the result. And the result here 3 plus d 3, and you notice that this definition is only contain 0 and 1 digit, but in here is 3. So in order to make to solve this one, we need to take 3 modulus by 2, because 2 is the binary. The binary is contain only 2 digits. So in here we need uh, to take 3 modulus by 2 digits in order to get the remainder 1 and 1 plus d. And in order for this code to see, in order to find the result of this code, first thing we need to know is d. D must equal to 1. We need to solve here. Why d must equal to 1? Because in order for the binary to equal to 0, d must equal to 1, because 1 plus 1 is 2, and 2 modulus 2 digit, and we will get 0, because 2 subtract 2 it 1, and 2 minus 2, the remainder will be 0. So in this exercise here, we need to add d1, another 1 in here, in order for the exercise is true. And move on to the another exercise 14 is consider the UPC 0, 4, 6, and so on, and show that this UPC cannot be correct. So as you already know that in this UPC, universal product code here, there are some numbers that are incorrect. So we need to show that the UPC cannot be correct. So in order to show this one, we need to check C multiply U equal to 0. And yeah, we assume the same because it is a UPC, it is 12 digit in here. So U multiply C and sum it up together, and we see the result is 77, and 77 modulus 10, we will get the remainder is 7. As you already know, 7 is the 7 here is not equal to 0. So it means that this UPC, there are some part of the number that are incorrect. And go to the exercise B, assume that a single error was made that the incorrect digit is the 6 in the third entry. Find the correct UPC. In B, they tell us that there are a single error in our code, which is the third entry. And in order to solve this one, the first thing we need to do is to replace 6 with D and assume the same. And we need to take C multiply U and plus and sum it up together, and we get the result is 59 plus 3D, and 59 is already bigger than 10 digit. Yeah, it is a decimal number, so we need to take 59 modulus by 10, and we get the remainder is 9 plus 3D, and we take 3 out, and 3 multiply 0 and 0, and so we get the result is 3 plus D. In order for this number to equal to 0, D must equal to 7, because 7 plus 3 is 10, and 10 modulus 10, we will get the remainder 0. So the correct UPC in here should be replace 6 with 7. And that's all for my presentation. And thank you, sir, for checking my presentation and pay attention, listen to my presentation. And thank you for teaching me through this first year. Goodbye, sir.